All right, inscribed angles today. Yes, sir. All right, the measure of an inscribed angle. Is half the measure of its intercepted arc. And we talked about this a couple of Thursdays ago when there was a question with an inscribed angle on your study guide. So, I said last week that if you've got a central angle and that central angle measures 40 degrees, right? Central angle has its vertex on the center. Then the measure of its intercepted arc is also 40 degrees. But if you were to take that angle, and if you could imagine the sides of this angle being a rubber band, and you just pulled it back twice as far, so now you pulled it back to here, yeah. It's going to affect the measure of the angle, isn't it? So, it's 20 degrees. Arc didn't change, did it? Both of the angles intercepted the arc at points A and B. So the arc doesn't change, the degree measure of the arc doesn't change. But when the vertex is on the center of the circle, then the central angle and the arc are the same. When the vertex is on the circle, then the inscribed angle is half the measure of the intercepted arc. So example 1 on the top of page 821. And all they're really doing on these problems is trying to mess with your eyes. And sometimes a highlighter is real helpful. You've got this picture. When you've done this for as long as I have, it gets a little simpler. And 120 is right here. The measure of angle RST. Yes. I don't know. Yeah, it looks like it. RST. I like to identify the angle. So I got a clear picture of the angle that they're asking me about. And once I highlight or color in that angle, then I try to see where does that angle end? Where do the ends hit the circle? And the sides of this angle hit the circle at R and T. So if this arc is 120, okay, well then what's this angle down here? It's 60 degrees. It's half the intercepted arc. So this is 60 degrees. And what if they ask for the measure of arc SU? Okay, arc SU. That's right here. S to U. And it has an inscribed angle. And its inscribed angle is 40. So what's the measure of arc S to U? That's going to be 80. Good. Any problems with that? Look at the check it outs. Check it out. Right below there you got that. And they tell you that this angle is 135. Measure of ADC. Arc ADC. And the measure of angle DAE. Arc A. 3 letters. So it's a major arc. It goes from A through D and it ends at C. So it's all the way around, isn't it? Here's its intercepted, or I'm sorry, here's its inscribed angle that ends at C and A. So this red arc all the way around the outside of that angle. It's going to be twice as big as the 135, isn't it? So 270. And then the measure of DAE, DAE relates to this 76-degree arc. So angle DAE would be 38, half of the 76, so 38 degrees. Questions? Look at that corollary there right below it. If inscribed angles of a circle intercept the same arc or are subtended by the same quarter arc, then the angles are congruent. let's see. So if you had a picture, you know, if you've got an inscribed angle here, and it's ABC, and another inscribed angle here, ADC, those two angles would be congruent. They both intercept the same arc. Okay? So the measure of angle ABC would be congruent to the measure of angle ADC. They both intercept this arc AC. So this angle is congruent to this angle. Look at the top of page 822. An inscribed angle. Subtends a semicircle. If and only if the angle is right, or if and only if the angle is a right angle. So that drawing looks like if you've got a circle and this diameter cuts the circle in half. So if an inscribed angle intercepts a semicircle, all right, the end points of this inscribed angle are on the diameter. Points A and B are on the diameter. A and B. All right, you got an inscribed angle. Its vertex is on the circle. Its end points are on the diameter. All right, that means it intercepts a semicircle. It makes this 90 degrees. Every time. All right, because this arc measure of this semicircle would be 180 degrees. But in most cases, they're not going to put the 180 on there. If you see that the inscribed angle ends on a diameter, that means that it's going to be a right angle in there. And it also forms a right triangle, doesn't it? Okay? So there's a picture. You get a picture in that example 3A where they don't give you this symbol. They give you this picture and they make that angle equal to 4x plus 6 and they ask you to solve for x. That's all you're given. Okay? But you'll know by definition that since this inscribed angle ends or intercepts a semicircle, that angle is equal to 90 degrees. So 4x plus 6 is equal to 90 degrees. So you can subtract 6. Your 4x is equal to 84. Divide by 4. And x equals, I'm going to guess 21. 21. Anybody got any questions? If the inscribed angles end at the same place, then the angles are equal to each other. Okay? If an inscribed angle ends on a diameter, then the angle is equal to 90. That's pretty much all we talked about today. So, you want a little bit of practice to do? Good. How about page 824? And let's see, do 2 through 9. (12 to 15). 17 and 18.